Example 3 is an inclined plane. These are a little tricky. So our body of mass 20 kilograms is placed on a smooth plane inclined at 30 degrees to the horizontal. So you can see what's going on here. We have the mass is there. Okay, its mass is 20, so that's going straight down. So you can see how that weight is in there, that force pushing down. We also have our angle to the horizontal of 30 degrees. Okay, a string is attached further up the plane, which prevents the body from moving. Calculate the tension in the string and the magnitude of the force exerted on the body by the plane. Now, the force exerted on the body by the plane is going to be our normal, and our tension is going to be, in this diagram, this F. So that's our tension. Now we need to put some information into our diagram. So I'm going to draw a horizontal coming across here, so we know that that's the right angle. We also know that this is a right angle here. Now that 30 degrees is there because of corresponding angles. So just quickly, and I'm going to get rid of it, but to see those corresponding angles, there's your F. Now that means this whole angle here has to be 90 plus 30, which is 120 degrees. So now we can work out this final angle over here using 360. That angle there is going to be 360 minus 90 minus 120, which is 150 degrees. So let's try and draw a triangulation of vectors. I'm going to start by just drawing that diagram without the inclined plane. It's going to be a bit easier to see what's going on. So that is N, that is F, and this is 20. We have our 120 degrees, our 90, which I've already put, and our 150 degrees here. Now if I move my 20 over here, that means this angle in here needs to be 180 minus 120, which is 60 degrees because they're co-interior. So this is 60 degrees. And my normal force I can bring this way. So I'm going to extend that down, and that works. So this is N. All of that was 120. We know that this is a right angle, so that means that angle in there has to be 120 minus 90, which is 30 degrees. Reason for that is that means that that angle there is 30 degrees because it's alternate. So we have everything that we need. Now I would recommend taking your time with these diagrams. It would save you more time in the long run. Also, the biggest thing that would get missed in this picture is that this is 90 degrees. So we're dealing with a right angled triangle. Okay, so if it helps you see that, I know I've got lots of drawings. This is a right angle, we have F, we have 20, and we have N there, 60 and 30. Okay, which angle you use is up to you, whether it's the 60 or the 30, it doesn't really matter. I'm going to go with the 30, so opposite, hypotenuse and adjacent. Let's start by finding O. So O and H, that's sine. Sine theta is opposite over hypotenuse. Sine 30 is F over 20. So F is 20 times sine of 30. Sine of 30 is an exact angle, it's half. So 20 times a half equals 10. Now let's find our n, and we can use Pythag. C squared is a squared plus b squared. 20 squared is 10 squared plus n squared. So n squared is going to be 20 squared minus 10 squared. 400 minus 100, which is 300. So n is the square root of 300, which can be simplified to 10 root 3. Finish with a therefore statement. So therefore the tension in the string is 10 kilograms weight and the force exerted by the plane is 10 root 3 kilogram weight.